Let's say someone sends an email to a person at a company and that person never opens it, never clicks anything, maybe never even sees it. A few hours later, they ask their AI assistant a totally normal work question, something like, summarize my meetings this week. And while it's answering that assistant quietly collects the person's private emails and files and sends them off to whoever sent that first email. So no link gets clicked, no attachment gets opened, nothing gets installed. The email just lands in the inbox and sits there. And that's all the attacker needs. So this is a real attack. It's called EchoLeak and it's tracked as CVE 2025 32711. It's found by researchers at AIM Security in 2025. And it's rated critical at 9.3 and it affected Microsoft 365 Copilot across Word, Excel, PowerPoint, Outlook, and Teams. Now, this attack got a lot of attention because it was the first known zero-click attack on an AI agent, and Microsoft has since patched it, but the idea behind it isn't going away because it's not really a bug in one product. It's a problem with how AI assistants that read your company's data are built in the first place. Everything here comes from the public advisories, AIM Security's write-up, and the research paper they wrote on it. It's called Journey Beat 10 times in case you want to research online. I have simply distilled all of the publicly available information into these nice diagrams here. So it's going to be a very visual video. I want you to stick around till the end if you want to completely understand how this attack works. First, let's talk about what Copilot really is. Microsoft 365 Copilot is an AI assistant wired into your work account. And the whole point of it is that it can read your stuff to help you. So you ask it a question, it can look through your emails, your files in OneDrive, and SharePoint, and your team messages, and then pull together an answer. The way it does this has a name. It's called RAG, Retrieval Augmented Generation, and most of you already know how it works. But in plain terms, when you ask a question, the assistant first pulls the most relevant pieces of your data, drops them in front of the model as background, and the model writes its answer using them. So Copilot is essentially constantly reaching into your private company data and feeding pieces of it to the model, and that's the whole feature working as intended, and it's also exactly what the attack abuses. Now, the structure of this attack is a little different from most, so it's worth getting it straight up front. Most attacks only worry about one direction, which is something bad getting in. EchoLeak works in two directions, and it helps to think of them as two separate doors. The first door is the way in, which is the attacker's instructions get into the model's context, and not by hacking anything, they just ride in on that retrieval step we just talked about. Copilot pulls in the attacker's content as if it were just more of your data. And the second door is actually the way out. Once the model is following the attacker's instructions, it needs to actually send your data somewhere. And it does that through the assistant's own reply, which carries the data out without anyone noticing. So untrusted instructions come in through retrieval and your private data goes out through the response. These are two separate doors, and pretty much everything in this video is about how the attacker gets each one opened. So let's talk about the first door, which is the way in. The attacker writes an email and sends it to someone at the target company. On the surface, it looks like a completely ordinary email, a newsletter, a product update, anything that's very ordinary. But buried inside it are instructions meant for the AI and not for the person. The attacker hides them somewhere a human won't notice, which is inside the HTML comments or as white text on a white background. So even if the person glances at the email, all they see is regular normal content. The important part here is that the attacker never needs the users to read the email, click, or reply. It just needs the email to land in their inbox and sit there. There is no attachment, no link to click, or no code anywhere. It's just pure text, and it's just instructions sitting in an inbox waiting to be picked up by the Copilot. So how do those hidden instructions reach the AI in the first place? The trick is that the attacker doesn't deliver them to Copilot directly. They let Copilot go and fetch them on its own. So remember how RAG works? When the person asks a question, Copilot retrieves the most relevant pieces of the data. So the attacker writes the email to look highly relevant to the kinds of things people ask Copilot about, packed with the right words and topics, so that later, when the person asks something totally normal, Copilot's retrieval step looks at this email, decides it's a good match, and pulls it into the model's context. And to improve the odds, the attacker can spread the payload across a lot of emails. And there's a name for this attack. It's called RAG spraying. So at least one of them gets retrieved during some real question down the line. The person just asks an innocent question, and the poisoned email comes along for the ride next to the genuine results. And that gets the attacker through the first door. Now, the hidden instructions are sitting in the model's context, mixed right in with the person's real data. And this is where we hit the root problem behind basically every AI attack. The model can't tell the difference between data it's only supposed to read and instructions that it's only supposed to follow. So to the model, it's all just text in the same window. So it goes ahead and does what the attacker's text tells it to do. And AIM security has a name for this. It's called an LLM scope violation, where untrusted outside input gets the model to reach into data it's allowed to touch and leak it, even though it should never be exposing it. And the reason that's so bad here is that Copilot can reach everything the signed-in person can reach, all their emails, all their files, all their messages. So the attacker's instructions don't just ask for one small thing. They point the model at the person's own data and tell it to go find the most sensitive material and get it ready to send out. The assistant here is just trying to be helpful, and that's exactly what makes it useful to the attacker. Now, let's talk about the second door, which is getting the stolen data back out. And this one's a bit counterintuitive, so I'll go a little bit slow. When Copilot writes an answer, it can include images the same way a web page does, and an image in a reply is really just a web address. It's an instruction that says, go fetch the picture at this location. Now, the key detail here is that Copilot's app loads those images automatically to display them without the person clicking anything. So the attacker's instructions tell the model to put an image in its reply, except the image's address doesn't point to a real picture. It points at the attacker's own server with the stolen data packed into the address itself. When Copilot displays its answer, the app automatically tries to load that image, which means it automatically sends a request off to the attacker's server, carrying the data along inside the address. So the attacker doesn't have to do anything else. They just read the data straight off their own server logs. Meanwhile, the person sees a perfectly normal, helpful answer and has no idea their app has just sent their data out. And this is what makes it zero-click. The app itself does the sending just by loading an image. Now, obviously, Microsoft is not naive about this. They had defenses built specifically against this kind of thing. What makes EchoLeak impressive and worth studying is that the researchers chained together several bypasses to get past all of them. And this is the point where the AI attack starts leaning on classical web hacking. Microsoft has a classifier called XPIA, whose entire job is to catch prompt injection attempts. The researchers got past it with a pretty simple idea. They phrased the hidden instructions as if they were written for the human reading the email rather than for the AI. The classifier is looking for text aimed at the model, so it didn't flag this, but the model read it and followed it anyway. Next, Copilot tries to strip out external links and images, so they wrote the malicious image link in an unusual, less common format that the filter did not recognize as a link. And then the strongest defense of all, the browser only lets images load from a list of trusted Microsoft domains and not from some random attacker site. So instead of pointing straight at their own server, they routed the request through a trusted Microsoft proxy, which was a Microsoft Teams image service that was already on the allowed list, and let that fetch the attacker's address for them. Because the request went out through a Microsoft domain, the browser let it through. So 3 separate defenses, each one beaten by stacking an old web trick on top of the AI trick. So let me show you the whole attack chain in one go. The attacker sends an email with hidden instructions inside it. Sometimes later, the person asks Copilot a normal question, and Copilot's retrieval pulls that poisoned email into the model's context, and the model follows the hidden instructions and gathers up the person's most sensitive data. It then writes that data into an image link in its reply, and the app auto-loads the image, which sends the data out through a trusted Microsoft proxy and onto the attacker. So you can notice that there are 0 clicks the entire way, and all that the person ever sees is a helpful answer. Okay, now I quickly want to pause here. You just watched the whole chain play out in the diagrams, but you can't and you should not run this against the actual real Microsoft Copilot because it's a managed Microsoft service and it's already patched. But I built labs where you can test out these attacks on your own. And all these labs are part of the Armor Dojo. I'll leave the link to the dojo in the description of this video. Most of the labs are completely free to try out, but some of them do have paid access, and those are the more advanced ones, because most of these labs are difficult to build and maintain. All right, now back to the video. So here is the part that made this attack such a big deal. For a long time, most people thought of prompt injection as basically a content problem. You trick the chatbot into saying something rude or off policy. It's annoying, but it's not really a breach. But EchoLeak is what changed that. It was the first time prompt injection got turned into real concrete data theft in a live production AI environment. So this was not a lab demo, but the actual Microsoft Copilot that's running inside companies everywhere. And the thing that made it possible was that second door. In most attacks, you're worried about bad input reaching something dangerous. But here, the model's own output was the dangerous part because the app renders that output and automatically loads whatever's inside it. So the lesson worth noting here is that with an AI assistant, the reply is not just text sitting on a screen, it's a channel that can reach out to the outside world. The output is an attack surface in its own right. So EchoLeak is not a one-time fluke. In 2026, researchers at Varonis disclosed a follow-on called SearchLeak. And it is tracked as CVE 2026-42824. And that chained together the same basic idea. One AI weakness tagged on a couple of old web bugs and again used a trusted Microsoft image service. This time it was Bing's service to slip out data past the browser's rules. Because the link pointed at a real Microsoft.com address, the normal phishing and link filters had no reason to flag it. So it's the same idea, just a different doorway. And when the same pattern shows up again a year later in the same product, that tells you something. This isn't a one-off mistake someone made. It's the natural result of the way these assistants are built. So let's talk about the stakes here. Anything inside Copilot's reach was exposed, like chat logs, OneDrive files, SharePoint content, team messages, any organizational data that has been preloaded for the assistant. And because Copilot can reach whatever the signed-in person can reach, the attacker basically inherits that person's access without ever logging in as them. It's also almost invisible from a defender's point of view. There is no malicious file to scan, no malware signature, no obvious alert, because as far as the system is concerned, nothing actually broke. The assistant just did what it was asked. And for companies in finance, law, healthcare, or government, that's the real problem. Your most sensitive data leaving through the exact tool you brought in to help you, and then that tool barely leaving a trace behind. And here's the part that actually outlives this specific CVE. It really isn't a Copilot problem. It's a problem with this whole category. Any AI assistant that reads your private data to help you and can also show links or images in its replies. So for any AI assistant you come across, you can ask two questions, one for each door. First, can untrusted outside content get pulled into the model's context through retrieval, an email, a shared document, a web page that it can read? And second, can the model's reply reach back out to the outside world through a link or an image that the app loads on its own? If the answer to both is yes, then you've got the same setup EchoLeak used, no matter what the product is called. And that applies to basically any LLM assistant wired into multiple internal data sources. And those two questions are going to stay useful long after this particular bug is forgotten. So why can't we just fix it? We can just filter out the bad instructions before they reach the model, right? Now, EchoLeak is a good demonstration of why that's hard, because the attacker hid the text from humans and phrased it to slip past the AI guard and disguised the exfil link so the filters did not catch it. So you're basically relying on that same confused model to sort good text from bad text, and a determined attacker just keeps finding new phrasings that get through. The fixes that do hold up are structural and they split along the same two doors. On the way in, the move is to give the assistant less to reach in the first place. So scope its data access tightly so that even if it does get hijacked, there's far less it can actually grab. And that's just the least privilege principle applied to AI. Now on the way out, you control the output channel so you don't let the app auto-load external images, and you keep strict rules about where content is even allowed to load from, and you don't let a trusted proxy forward requests off to arbitrary places. It's the same lesson underneath both. Instead of trying to recognize every possible bad input, you shrink what the system is allowed to do on each end. So let's see what we can learn from this video. If you run an AI assistant like Copilot, your biggest lever is data governance. Limit what the assistant is allowed to index and reach so that any future leak comes away with less. Be careful about letting it ingest external email and shared documents because that's door one right there. And since you usually can't patch a managed service yourself, pay attention to the output side as well. Watch for the assistant's responses carrying odd encoded links or making unusual outbound image requests. Now, if you're the one building an AI assistant, treat every piece of retrieval content as untrusted attacker input, because anything the model reads could have been planted by someone else, and take the output just as seriously as an attack surface. Never let the model emit a link or image that the client is going to fetch from an untrusted location. Put the same amount of care on what comes out as you do on what goes in. So that second door, which is the exfiltration door, is the one that almost everyone forgets about, and it's exactly the one that EchoLeak went through. Okay, so now let's wrap this up. EchoLeak is a single email that steals your data with 0 clicks. The hidden instructions write into the assistant through retrieval, get it to turn on its own user, and send the data out through an image that the app loads by itself, and it slips past Microsoft's defenses by stacking a few classic web tricks on top of the AI trick. The deeper point here is those two doors, so untrusted content can get in through whatever the assistant reads, and your data can get out through whatever the assistant says back. The reply from the model is not just a text on a screen, it's actually a channel which the attackers can use. Okay, so here's what we can take away. With an AI assistant, retrieved content is untrusted input, and you should treat it that way. The model's output is actually an attack surface, so never let it fetch things from places you don't trust. And the real fix is to limit access on the way in and control the channel on the way out, not to sit there hoping you can filter out all the bad wording. And for any assistant that you run into, ask those same two questions. Can untrusted content get into its context? And can its output reach the outside world? And if you want to go through attacks like these on your own, I build labs in the Armor Dojo, and I will share the link in the description of this video. Now, it takes a lot of time to research these attacks and process and condense all of that information into these nice diagrams. So make sure you subscribe to this channel and like and share this video, and I will see you in the next one.